somewhere in the western Atlantic Ocean, between the coast of Florida, the island of Puerto Rico, and the archipelago of Bermuda, there is a stretch of water that has no official boundary. No government has drawn a line around it. No nautical chart marks it in red. You could sail through the middle of it and feel nothing unusual, just the warm Caribbean wind, the deep blue of the Gulf Stream, the ordinary vastness of the open sea. And yet this stretch of water has a name known to almost every person alive: the Bermuda Triangle. It is a place that exists, in some sense, more powerfully in the imagination than on any map. A place where ships have vanished without sending distress signals, where aircraft have disappeared in clear weather, mid-transmission, with no wreckage ever recovered, where compasses have behaved strangely, where experienced, careful professional sailors and pilots have reported seeing things they could not explain, and then, in some cases, have not been seen again. Or so the stories go. In the next 2 hours, we're going to walk through all of it. Every major theory, every famous disappearance, every proposed explanation, from the scientific to the extraordinary. We'll begin with the history of how the triangle became famous, because it didn't always have this reputation, and the story of how it acquired one is interesting in itself. We'll move through the well-known theories: unusual weather, methane hydrates, magnetic anomalies, human error, and then we'll go deeper into the stranger waters. Theories involving ancient civilizations, underwater technology, time distortions, and intelligences that may or may not be native to this planet. Some of what you'll hear tonight is documented. Some of it is the sincere belief of researchers who have spent careers following these threads across the Atlantic. And some of it is, depending on your perspective, the most fascinating mythology of the modern age. We won't be deciding which is which. Let's start at the beginning. The Bermuda Triangle, as a concept, is surprisingly young. The area itself has been sailed for centuries. Columbus crossed through it in 1492, and his journal contains a curious entry, a note that his compass behaved oddly in those waters, and that he and his crew observed a strange light descending toward the ocean's surface one night. Whether these observations mean anything is genuinely debated. Compass variation in that region is a real navigational phenomenon, and a distant meteor could explain a descending light. But the entries are there in the oldest European record of the region. It is worth pausing on that for just a moment. Columbus was not a superstitious man by the standards of his time. He was a professional navigator, careful, experienced, deeply attentive to the behavior of his instruments and the conditions around him. The fact that he thought the compass anomaly worth recording suggests it was not trivial. The fact that he mentioned the descending light at all in a logbook primarily concerned with coordinates and weather conditions suggests it was genuinely unusual. He didn't know what it was. He wrote it down, and he sailed on. And for most of the centuries that followed, the area between Florida, Bermuda, and Puerto Rico was simply the sea. Sailors crossed it. Ships were sometimes lost there. But ships were sometimes lost everywhere. The Atlantic is a large, frequently violent body of water, and the age of sail was an age of high maritime mortality. There was nothing in the navigational literature for most of this period suggesting that this particular stretch of water was unusually dangerous. The trade winds that run through the region made it a natural corridor for ships moving between Europe, Africa, and the Americas. Spanish galleons, laden with gold from the New World, crossed it regularly. British naval vessels patrolled its edges. Merchant ships, slave ships, fishing vessels, all of them used these waters as a matter of routine. They were lost sometimes, as all ships were lost sometimes. The Caribbean is prone to hurricanes. The Atlantic is prone to storms. The sea was, and remains, genuinely dangerous, and the men and women who sailed it understood that. There was no triangle. There was just the ocean. The idea of the triangle as a specifically cursed or mysterious region began to take shape in the mid-20th century. And the way it took shape tells us something interesting about how mysteries are made. In 1950, a journalist named Edward Van Winkle Jones published a short article in a Miami newspaper about a series of unexplained disappearances in the area. The piece was brief and factual in tone, a summary of several notable incidents, with the observation that the region seemed to claim an unusual number of vessels and aircraft. The article attracted some attention, but it didn't catch fire. It was one newspaper piece in one regional paper, making a modest observation. It was a piece published in 1964 in Argosy magazine by a writer named Vincent Gaddis that gave the mystery its name. Gaddis called it the Bermuda Triangle, a deliberate geographic framing that gave the mystery a shape, a boundary, an identity. The triangle is, of course, a geometrically significant form in esoteric and occult tradition. And whether Gaddis chose the name for that reason or simply for its dramatic quality, the choice was potent. A triangle has 3 points. It creates an enclosed space. It suggests something bounded, defined, specific, a zone rather than just a stretch of water. Once you call it the Bermuda Triangle, you have given people a place to look, a location to attribute things to, a frame through which to read incidents that might, in any other frame, look like ordinary maritime and aviation losses. Naming is powerful. It always has been. But the triangle truly entered the global consciousness in 1974, with the publication of a book called The Bermuda Triangle by Charles Berlitz. Berlitz was a writer with a gift for popular history, and his book assembled the full catalogue of triangle disappearances into a sustained, compelling narrative. It sold millions of copies worldwide. It was translated into dozens of languages. For an entire generation, the Bermuda Triangle became one of the defining mysteries of the age, discussed in classrooms, debated on television, featured in documentaries, and quietly absorbed into the background of cultural anxiety about the unknown. The timing mattered. The 1970s were a decade of unusual public appetite for the paranormal and the unexplained. Erich von Däniken's Chariots of the Gods had proposed ancient astronauts. Uri Geller was bending spoons on television. The counterculture's expansion of permissible belief had opened a space for phenomena that mainstream institutions neither endorsed nor could fully explain. Into that space, the Berlitz book arrived perfectly. That book is where most people first encountered the canonical list of famous disappearances. It's worth walking through the most significant ones carefully, because they form the foundation of everything that follows, and because they deserve to be told properly, not just cited. The most famous case is Flight 19. On the 5th of December, 1945, 5 United States Navy torpedo bombers, TBF Avengers, took off from Fort Lauderdale Naval Air Station in Florida for a routine training mission. The weather was clear. The aircraft were in good condition. The crews were experienced. The mission was a standard navigation exercise. Fly east, turn north, return west to base. It was the kind of flight these men had done many times. They never came back. The mission was scheduled to last approximately 2 hours. When no aircraft had returned after 3 hours, the station began trying to raise the flight by radio. They succeeded intermittently, and what they heard was disturbing. Lieutenant Charles Taylor, the flight leader, was reporting that his compasses weren't working, both of them. He was describing the ocean beneath him as not looking right, not the ocean he expected to see. He wasn't sure where he was. His transmissions, as the hours passed, became increasingly fragmented, partly because the aircraft were ranging further from shore, partly because of what sounded like genuine disorientation. The other pilots in the flight, younger and less experienced than Taylor, were audible on the recordings asking each other what to do, asking Taylor for direction. At one point, One of them suggested that if they could just fly west, they would reach land. Taylor, for reasons that were never fully established, seems to have believed he was over the Gulf of Mexico rather than the Atlantic, and his instructions directed the flight eastward, away from the Florida coast rather than toward it. The transmissions grew fainter, and then there was nothing. A search and rescue aircraft. A PBM Mariner flying boat sent out with a crew of 13 to find Flight 19 also disappeared shortly after takeoff. No distress signal was received from it either. No wreckage from Flight 19 was ever conclusively identified. No bodies were recovered. The Navy's official inquiry, after extensive investigation, listed the cause of loss as unknown, a phrase that is, in a military investigation accustomed to definitive findings, quite unusual. A subsequent review attempted to attribute the loss to Taylor's navigational error and revised the finding to pilot error, but Taylor's mother contested this revision vigorously, and it was eventually changed back to unknown, at her request. The Navy, in the end, did not know what happened. Flight 19 remains, to this day, the most discussed and most genuinely unresolved of all Triangle cases. A second major case predates the Triangle's naming by several decades: the disappearance of the USS Cyclops. The Cyclops was a United States Navy collier, a large vessel designed to carry coal and fuel to other ships at sea. In March of 1918, it departed Barbados, bound for Baltimore, carrying 309 crew members and passengers, and a cargo of manganese ore. The weather at the time of departure was reportedly calm. The ship was in good operational condition. No distress signal was ever received. No wreckage was ever found. No bodies were recovered. The Cyclops simply ceased to exist, somewhere in the Western Atlantic. The loss was investigated thoroughly by the Navy at the time, and several explanations were proposed. Structural failure due to the heavy ore cargo, an encounter with a German submarine, foul play related to the ship's German-born commander, who was later found to have had suspicious loyalties. None of these explanations were confirmed. The investigation was closed without a definitive finding. The USS Cyclops remains the single largest loss of life in United States naval history, not directly involving combat. 309 people vanished without a trace, in a busy stretch of ocean, with no explanation that has ever fully satisfied the investigators who examined it. Two sister ships to the Cyclops, the Proteus and the Nereus, also disappeared in the same region during World War II, also without explanation. The Navy attributed those losses to German submarines, which is plausible given the wartime context. But the cluster of three sister ships lost in the same region is a detail that Triangle researchers have found difficult to dismiss. A third case worth telling in detail: the disappearance of a Douglas DC-3 aircraft in December of 1948. The plane was a charter flight carrying 32 passengers from San Juan, Puerto Rico, to Miami, Florida. The pilot was experienced. The aircraft was airworthy. The night was clear. Approximately 50 miles south of Miami, the pilot radioed the Miami control tower to confirm his position and request landing instructions. He reported that the weather was good. He said he could see the lights of Miami clearly ahead of him. He asked for landing coordinates. The tower acknowledged. The pilot acknowledged the acknowledgement. And then the radio went silent. The aircraft was never found. The passengers were never found. In the days that followed, an extensive search of the waters south of Miami found nothing. No wreckage, no debris, no fuel slick, no personal effects. 32 people and one aircraft on a clear night within sight of a major city, gone without a trace. These are 3 cases. There are dozens more. Yachts found drifting and empty, with meals still on the table and no sign of struggle. The crew simply absent, as if they stepped off the edge of the world between one moment and the next. Private planes. but vanished from radar mid-flight on clear days. Military vessels reported missing at sea with no emergency transmissions. Small craft that left harbour in calm weather and were never seen again. The list, assembled by Berlitz and expanded by subsequent researchers, runs into the dozens of cases spanning more than a century. Each one is, in isolation, the kind of maritime or aviation incident that occurs somewhere in the world's oceans with some regularity. Taken together, collected under the name of a specific region, they create the impression of something systematic. Now, it is worth introducing a significant complication here before we move into the theories, because the mythology of the triangle deserves to be understood, not just repeated. In 1975, just 1 year after Berlitz's book became a global sensation, a librarian and researcher named Lawrence David Cush published a book called The Bermuda Triangle Mystery Solved. Cush had done something that, in retrospect, seems obvious, but apparently hadn't been done systematically before. He went to the original sources. He didn't rely on other triangle books, or on accounts that cited other accounts that cited other accounts. He tracked down the official investigation reports, the Lloyd's of London insurance records, the Coast Guard files, the actual weather reports from the date of each incident, the contemporary newspaper accounts from when each disappearance occurred, and he compared them point by point to the way the stories had been told in the triangle literature. What he found was significant. In many cases, it was devastating. Ships that Berlitz described as vanishing in calm weather had, according to the original records, actually disappeared in severe storms. Vessels that were listed as triangle casualties had been lost hundreds of miles outside any reasonable triangle boundary, some of them in the Pacific Ocean. Some incidents that appeared in triangle books had no verifiable source whatsoever, no newspaper account, no investigation record, no insurance claim. They appeared to have been invented entirely or confused with different incidents involving different vessels in different locations. Dates were wrong. Weather conditions were reversed. In several cases, wreckage had been found and reported in the original accounts, and Berlitz had either omitted this detail or explicitly written that no wreckage was ever recovered. The DC-3 disappearance in 1948, for example, turns out to have more ambiguity in the original record than the popular telling suggests. The Mary Celeste, the famous ghost ship often associated with the triangle, was actually found in the Atlantic near Portugal, thousands of miles from the triangle region, and its mystery is a separate and older one. Cush concluded that the Bermuda Triangle mystery was in large part a manufactured myth, assembled from misreported, selectively presented, and occasionally fabricated incidents, packaged into a compelling narrative, and sold to a public hungry for mystery. Lloyd's of London, the most authoritative maritime insurance market in the world, with several centuries of data on ship losses globally, does not charge higher premiums for ships sailing through the Bermuda Triangle. When asked directly about the region, their assessment has consistently been that it is no more dangerous than any other heavily trafficked stretch of ocean. For an institution whose entire business model depends on accurate risk assessment, this is a meaningful finding. The United States Coast Guard, which maintains detailed records of maritime incidents in the region, has reached similar conclusions. The triangle, in their official assessment, does not represent a statistically anomalous area for maritime loss. This is worth sitting with. It is real. Cush's research is methodologically sound, and much of it is genuinely damaging to the simpler and more dramatic versions of the triangle mystery. And yet, here is the thing that Cush's book didn't quite settle. And this matters. Not all of the cases yielded to his debunking. Flight 19, examined closely, does not collapse into a simple navigational error story Taylor's behavior and the content of his transmissions retain genuine strangeness. The USS Cyclops has no satisfying explanation, and neither do its sister ships. A handful of other incidents resist simple resolution even when examined with exactly the rigor and skepticism Kush brought. More than that, the systematic debunking of the case files doesn't fully account for a separate category of evidence: the reports of strange phenomena from people who had no reason to fabricate and no interest in promoting a mystery. Experienced, professional aviators describing instrument anomalies that they could not explain. Navigators reporting compass behavior inconsistent with known magnetic variation in the area. Pilots describing atmospheric phenomena unlike anything in their training or subsequent experience. These accounts were not assembled by Berlitz. They came from official filings, from cockpit voice recorders, from the log entries of professional mariners. They predate the triangle mythology and continue after it. Kusher answered the question he set himself. He demonstrated that the triangle legend was substantially constructed rather than observed. But the question of whether something genuinely unusual occurs in the region, underneath, and separate from the constructed legend is a different question. And that question he left, perhaps deliberately, somewhat open. So we arrive at the triangle in a complicated and honest place. The mythology around it is real, and a significant portion of it is manufactured. The mystery underneath the mythology is also real, though smaller, stranger, and more specific than the popular version suggests. It resists the simple version on both sides. It is neither the supernatural death zone of popular imagination, nor the completely ordinary stretch of ocean that the most emphatic debunkers describe. It is a place with a documented history of genuine incidents that have not been fully explained, a place with a deep and complex geology that has not been fully mapped, a place where, on occasion, the instruments of experienced professionals have behaved in ways that the professionals themselves could not account for. And it is a place onto which generations of humans have projected their deepest uncertainty about what the natural world contains. With that foundation in place, honest, complicated, and deliberately unresolved, let's look at what people actually believe. Unusual weather and the Gulf Stream. The most widely accepted scientific explanation for the triangle's reputation begins with geography and meteorology. The Bermuda Triangle sits at the intersection of several powerful and occasionally violent natural systems. It is not a calm or passive region of ocean. It is, in many ways, a meeting place, where warm and cool waters interact, where atmospheric systems collide, where conditions can shift from stable to dangerous with very little warning. At the center of this is the Gulf Stream. The Gulf Stream is not just a current. It is a massive, fast-moving river within the ocean, carrying warm water from the Gulf of Mexico up along the eastern coast of the United States, and then out across the Atlantic toward Europe. Its scale is difficult to visualize. It transports more water than all the rivers on Earth combined. In the Triangle region, this current can reach speeds of up to 5.5 miles per hour. That matters more than it might seem. If a vessel sinks in still water, debris tends to remain near the site of the incident, at least initially. Rescue teams can triangulate the last known position and search outward. But in the Gulf Stream, that process breaks down almost immediately. A piece of wreckage floating on the surface can be carried miles away in a matter of hours. Within a day, it may be dozens or even hundreds of miles from where the vessel actually went down. This creates a specific kind of mystery. Search teams arrive at the last known coordinates and find nothing. No debris, no oil slick, no life rafts. The absence of evidence begins to feel like evidence of absence, as if the vessel simply vanished. In reality, the evidence may have been swept away before the search even began. For aircraft, the effect is similar. If a plane goes down at sea, the initial debris field may be small, and in a strong current, it disperses quickly. By the time search operations begin, the surface clues may already be gone. The ocean keeps its surface clean, especially when it is moving. Now add weather. The Bermuda Triangle lies within a region where tropical and subtropical weather systems form and evolve. Warm ocean water fuels atmospheric instability. Storms can develop rapidly, intensify quickly, and shift direction unpredictably. What begins as a calm afternoon can become a dangerous situation within hours. This is particularly true during hurricane season, but even outside of it, the region experiences sudden squalls, intense, localized storms that can reduce visibility to near zero and generate strong winds and waves in a very short time. For a small vessel, or even a mid-sized one, this can be enough. A sudden squall can disorient a crew, overwhelm navigation systems, and create conditions where a single mistake becomes difficult to recover from. A boat can capsize, a plane can lose visual reference, communication can fail at exactly the moment it is needed most. And then the storm passes. By the time anyone realizes something is wrong, the sky may be clear again. Waterspouts are another feature of this region. They look, from a distance, almost delicate, thin funnels descending from clouds to the ocean's surface. But they are, in effect, tornadoes over water. They can form quickly and move unpredictably. A vessel or low-flying aircraft encountering a waterspout directly would be subjected to intense rotational winds and pressure changes, potentially catastrophic, depending on proximity and strength. Then there are rogue waves. For a long time, rogue waves were considered more folklore than fact. Stories from sailors about walls of water appearing suddenly in otherwise manageable seas. But modern measurements, including satellite data and instrumented buoys, have confirmed that rogue waves are real. They are large, isolated waves that can rise to heights far exceeding the surrounding sea state, sometimes appearing without clear warning. A ship encountering one head-on may survive. A ship struck from the side may not. Smaller vessels are particularly vulnerable. The Bermuda Triangle, with its complex interaction of currents and weather systems, is a plausible environment for the formation of such waves. And then there is the traffic. This is one of the most important and often overlooked elements of the explanation. The triangle is not a remote or rarely visited part of the ocean. It is one of the busiest maritime and aviation corridors in the world. Commercial shipping routes pass through it continuously. Cruise ships, cargo vessels, private yachts, military operations, and a dense network of flight paths connecting North America, the Caribbean, and South America all intersect in this region. This means that even a normal rate of accidents will produce a relatively large number of incidents simply because of the volume of activity. More ships, more planes, more opportunities for something to go wrong. When people began collecting stories of disappearances in this region, they were drawing from a very large pool of events. And once the region was labeled, once it became the Bermuda Triangle, the process became self-reinforcing. Incidents that might previously have been recorded as isolated maritime losses were now grouped together under a single narrative. Pattern emerges when attention is focused. This is what organizations like the United States Coast Guard and Lloyd's of London have pointed out in their analyses. When you compare the rate of incidents in the triangle to other heavily trafficked regions of the ocean, adjusting for the number of vessels and flights, the triangle does not stand out as unusually dangerous. It looks, statistically, normal. This is a serious point, and one that carries weight. It suggests that much of what we perceive as mystery may be the result of framing, of grouping events together in a way that makes them seem connected when they are not. The human mind is very good at seeing patterns, especially when those patterns are suggested by a compelling story. And yet, even within this explanation, one grounded in well-understood science, there are edges that feel slightly unresolved. Weather explains many disappearances, but not all of them clearly. The Gulf Stream explains why wreckage is hard to find, but not why some vessels seem to leave no trace at all, even in conditions where some trace might be expected. Traffic volume explains frequency, but not the specific details of certain cases that remain difficult to reconstruct. The scientific explanation is strong. It accounts for a great deal. It may account for most of what has been attributed to the triangle, but it does not close the story completely. And it is in those small remaining gaps, the places where the explanation is solid but not absolute, that the other theories begin to take shape. The next one begins beneath the surface of the ocean itself. Methane hydrates in the 1980s and 90s. A series of oceanographic studies drew attention to a phenomenon on the floor of the Western Atlantic that offered a new kind of explanation for the triangle mystery: methane hydrates. At first, the term sounds abstract, but the substance itself is simple to describe. Methane hydrate is sometimes called fire ice. It looks like frozen snow or compacted ice, but it contains methane gas trapped within a lattice of water molecules. It forms under very specific conditions, low temperatures and high pressures, which are found in abundance on the deep ocean floor, across large areas of the world's continental shelves, including regions near the Bermuda Triangle. These hydrates exist in vast quantities. Some estimates suggest that more carbon is stored in methane hydrates globally than in all known fossil fuel reserves combined. For the most part, these deposits are stable. They sit quietly beneath layers of sediment, held in place by pressure and temperature conditions that have remained relatively constant for thousands of years. But not always. Under certain circumstances, a shift in ocean temperature, a drop in pressure, tectonic movement, or even underwater landslides, these deposits can destabilize. When they do, the methane trapped within them is released, sometimes gradually and sometimes in sudden large bursts. It is these sudden releases that capture the attention of researchers. Imagine a large pocket of methane beneath the seabed becoming unstable. The gas expands rapidly, pushing upward through the sediment and into the water column. As it rises, it forms a plume, a column of bubbles moving toward the surface. If the release is large enough, the water in that column becomes something different from the surrounding ocean. It becomes less dense. And this is where the theory becomes particularly interesting. A floating object, a ship, for example, relies on the density of water to stay afloat. The principle is simple. The weight of the water displaced by the vessel must equal the weight of the vessel itself. If the water becomes less dense, the same volume of displaced water provides less buoyant force. In a sufficiently large methane plume, the density of the water can drop enough that a vessel above it suddenly loses buoyancy. In effect, the ocean stops holding it up. Laboratory experiments have demonstrated this effect on a small scale. Objects placed in water infused with gas bubbles sink more easily than in pure water, in controlled conditions. The principle works exactly as the theory predicts. Scaling this up to the ocean is more complex. For a ship to be significantly affected, the methane release would need to be both large and concentrated. The plume would need to reach the surface with enough intensity to alter the density of the water across an area comparable to the size of the vessel. Is that possible? Some researchers believe it is. In the Barents Sea, off the coast of Norway, scientists have identified large craters on the seafloor, some hundreds of meters wide, that appear to have been formed by sudden methane releases. These craters suggest that, under the right conditions, substantial and rapid gas eruptions can occur. The question is whether similar events happen in the Bermuda Triangle region. Geological surveys have identified methane hydrate deposits along the continental margins of the Atlantic, including areas not far from the triangle. The conditions for hydrate formation exist. The potential for destabilization exists. But direct evidence of large-scale methane eruptions occurring in the triangle at the surface in real time remains limited. There is also the question of frequency. Even if such eruptions can happen, how often do they happen? Often enough to account for multiple unexplained disappearances over decades. Or are they rare, isolated events that would be unlikely to intersect with a vessel or aircraft at exactly the wrong moment? This is where the theory becomes less certain. For ships, the methane explanation has a certain quiet logic. It offers a mechanism for sudden disappearance without distress signals. A vessel encountering a large plume might sink rapidly, leaving little time for communication. The rising gas could disrupt engines. The dispersal of debris by currents could erase surface evidence before search teams arrive. It is not a dramatic explanation. It does not require intention or intelligence. It is simply a natural process, occurring in a place where natural processes are not always gentle. For aircraft, the theory takes a different form. If a large methane release reaches the surface and continues into the atmosphere, it could create a localized region of methane-rich air. Methane, in high concentrations, can affect combustion. Aircraft engines rely on precise fuel-air mixtures. If that mixture is disrupted, if the incoming air is diluted with methane, engine performance could degrade or fail. Additionally, methane is less dense than air. A significant concentration could alter lift characteristics in subtle ways, potentially affecting aircraft stability. There is also the possibility of electrical effects. Some researchers have suggested that large methane releases could ionize the surrounding air, creating conditions that interfere with onboard electronics or navigation systems. Again, these are plausible mechanisms, but plausibility is not proof. No specific aircraft disappearance in the Bermuda Triangle has been conclusively linked to a methane event. There are no recorded cases where a methane plume was directly observed causing an aircraft malfunction in this region. What exists instead is a convergence of possibility, a known substance, a known mechanism, a known presence in the region, and a set of unexplained events that the mechanism could in theory account for. This is why the methane hydrate theory continues to appear in serious discussions of the triangle. It occupies a middle ground. It does not dismiss the mystery entirely. It acknowledges that something unusual could be happening beneath the surface. But it also keeps the explanation within the boundaries of known science. There are no lost civilizations, no distortions of time or space. Just geology, chemistry, pressure, temperature, and the quiet reminder that the ocean floor is not static. It shifts. It stores energy. It releases that energy, sometimes slowly, sometimes suddenly, in ways that are not always visible from above. We have mapped only a fraction of it in detail. Much of it remains, even now, in partial darkness, known in outline, but not in texture, not in behavior. The methane hydrate theory, in its simplest form, says this: there are processes happening beneath the ocean that we do not fully observe. Some of those processes can have dramatic effects at the surface, and occasionally those effects may intersect with human activity in ways that leave very little trace. That idea does not belong only to the Bermuda Triangle. It belongs to the ocean as a whole. And the ocean, as we are still learning, is capable of more than we once assumed: magnetic anomalies and compass variation. One of the oldest observations associated with the Bermuda Triangle, going back, as we noted, to Columbus himself, is the strange behavior of compasses in the region. This is an observation with genuine scientific grounding, though not in the way the mythology usually presents it. To understand it properly, it helps to slow down and look at what a compass is actually doing. A compass does not point to the geographic North Pole. It points to magnetic north, a point determined by the Earth's magnetic field, which is generated by the movement of molten iron in the planet's outer core. This magnetic field is not fixed. It shifts, slowly but continuously, over time. the position of magnetic north drifts, the strength of the field varies, and the shape of the field is not perfectly symmetrical. Because of this, the direction a compass points, magnetic north, is usually offset from true north by some angle. This difference is called magnetic declination. Navigators have always had to account for this. On nautical charts, declination is carefully marked. A sailor using a compass must adjust their heading based on the known difference between magnetic and true north at their location. In the age before electronic navigation, this was not optional. It was fundamental to reaching the correct destination. Now, here is where the Bermuda Triangle enters the story in a subtle but important way. There are, at certain times in history, lines across the Earth where magnetic north and true north align. These are called agonic lines, zones of zero declination. Along these lines, a compass points directly to true north without correction. This might sound convenient, but for navigators accustomed to applying a correction, it can actually introduce confusion. Historically, one of these agonic lines passed through the Bermuda Triangle region. A sailor expecting a certain degree of magnetic variation, based on charts or experience from nearby regions, might apply a correction that was no longer necessary. The result would be a navigational error, subtle at first, but increasing over distance. Over open ocean, a small error in heading can become a large error in position. If you are off by just a few degrees over the course of several hours, you may miss your destination entirely. In a region with many islands, shoals, and shifting weather, that kind of error can become dangerous. This is one of the simplest and most grounded explanations for early reports of compass anomalies in the triangle. The compass was not malfunctioning. It was behaving correctly, but the navigator's expectations were not aligned with the actual magnetic conditions. And yet, that is only part of the story. Beyond declination, there are localized magnetic anomalies, areas where the Earth's magnetic field behaves in ways that are less predictable on a small scale. These anomalies are usually caused by variations in the composition of the Earth's crust. Certain rocks, particularly those rich in iron, can affect the local magnetic field. Underwater geological structures, including ridges, trenches, and volcanic formations, can create subtle distortions in magnetic readings. The Bermuda Triangle sits above a geologically complex part of the Atlantic. The Puerto Rico Trench, at its southeastern boundary, is the deepest point in the Atlantic Ocean. It marks the boundary between tectonic plates. The seafloor in this region is not flat or uniform. It is shaped by forces that operate over millions of years: subduction, faulting, sediment accumulation, and volcanic activity. This complexity can produce variations in the local magnetic field. In most cases, these variations are small. Modern instruments can detect them, map them, and account for them. But in earlier periods, especially before the widespread use of electronic navigation, such variations could be disorienting. A compass might not spin wildly or fail entirely, but it might drift slightly or behave inconsistently in a way that is difficult to interpret in real time. For a navigator already dealing with weather, waves, and limited visibility, even a small inconsistency can create uncertainty. And uncertainty at sea tends to compound. There are also reports, particularly from the mid-20th century, of more dramatic compass behavior in the Triangle region. Pilots describing compasses that spun or failed simultaneously. Navigators reporting instruments that seemed to stop responding altogether. These accounts are harder to evaluate. Some may reflect genuine instrument malfunction. Mechanical compasses can fail. Electrical systems can experience interference. In aircraft of that era, redundancy was limited compared to modern standards. Some may reflect perceptual confusion. In conditions of stress, especially when visual references are lost, over open water, in fog, or at night, The human brain can misinterpret instrument readings or perceive instability where there is none. But it is also possible that, in rare cases, localized electromagnetic disturbances could affect instruments in ways that are not fully predictable. Lightning, for example, can temporarily disrupt magnetic and electrical systems. Solar activity, though usually affecting higher latitudes, can influence the Earth's magnetic field. Underwater geological processes may, in theory, produce localized electromagnetic effects, though this is less well established. The key point is that the environment is not perfectly uniform or stable. For theorists, the compass anomaly observation carries weight because it connects multiple layers of the story. It links modern reports to historical ones. It provides a physical phenomenon, magnetic variation, that is measurable and real. And it suggests that the region may have environmental characteristics that are not immediately obvious, but are nonetheless significant. It grounds the mystery in something tangible. For skeptics, however, the same evidence leads to a different conclusion. Magnetic variation is well understood. It is mapped, updated regularly, and incorporated into all modern navigation systems. GPS has largely removed reliance on magnetic compasses for primary navigation. Even when compasses are used, they are part of a broader suite of instruments that cross-check each other continuously. In this context, magnetic anomalies are not mysterious. They are manageable. Modern aircraft and ships pass through the Bermuda Triangle every day, guided by satellite navigation systems that are unaffected by local magnetic variation. The disappearance rate in the modern era does not suggest a systemic problem with navigation in the region. The anomalies, in this view, are historical artifacts, real but no longer particularly dangerous. And yet, there is something about the compass that continues to resonate. It is a simple instrument, a needle aligning itself with an invisible force that surrounds the planet. When it behaves unexpectedly, it touches something deeper than technical navigation. It suggests that the underlying structure, the invisible framework we rely on to orient ourselves, may not be as stable as we assume. Even if the explanation is entirely scientific, the feeling it produces is something else. A moment of quiet disorientation. A reminder that the Earth itself is not static, that the forces beneath us are moving, shifting, reshaping the invisible lines we use to understand direction. In the Bermuda Triangle, that reminder has been recorded for centuries. And even if we now understand most of it, the memory of that uncertainty still lingers, like a needle that, just for a moment, refuses to settle. Human error and the fog of the sea. The theory that receives perhaps the least dramatic treatment, but which carries significant weight among professional investigators, is this. Most of what has been called the Bermuda Triangle mystery is, at its core, a story about human error in a demanding environment. Not careless error, not incompetence, but ordinary human misjudgment under pressure, the kind that can happen to anyone, especially in a place where small mistakes are not easily forgiven. The Western Atlantic and Caribbean are among the most heavily traveled waters in the world. They are also waters that present genuine challenges, rapid weather changes, strong currents, navigational complexity near numerous islands and shoals. And in the era of most triangle incidents, instruments and communication technology far less reliable than what exists today. To understand this theory properly, it helps to imagine the conditions more clearly. A pilot flying over open ocean has very few visual references. There are no roads, no landmarks, no fixed points, just water and sky, often indistinguishable at the horizon. On a clear day, this can feel serene. On a cloudy day, or at dusk, or in fog, it can become disorienting very quickly. Spatial orientation, the brain's ability to understand position and movement, depends heavily on visual cues. When those cues disappear, the brain begins to rely on internal signals from the inner ear. Those signals are not always reliable, especially during sustained motion, Pilots can experience what is known as spatial disorientation, the powerful and convincing sensation that they are level when they are not, or turning when they are not, or descending when they are actually climbing. Training teaches pilots to trust instruments over sensation. But that is easier said than done, especially if the instruments themselves are behaving unexpectedly, or if the pilot believes the instruments are wrong. Flight 19. The most famous case illustrates this clearly when examined in detail. Lieutenant Charles Taylor was an experienced pilot, but he was new to the Fort Lauderdale area, the geography of the region. The chain of islands, the shallow banks, the similar appearance of ocean in multiple directions can be confusing even in good conditions. His radio transmissions suggest a man trying to reconcile what he sees with what he expects to see, and failing. At some point during the flight, Taylor became convinced that he was over the Florida Keys, which would place him over the Gulf of Mexico. In reality, he was likely over the Atlantic, east of Florida. This single misidentification changed everything. If you believe you are west of Florida when you are actually east of it, the direction you choose to return to base will take you further out to sea instead of back toward land. This is how errors compound. Taylor's compasses may or may not have been malfunctioning. Even if they were functioning correctly, his interpretation of them was shaped by his belief about his location. The other pilots in the flight expressed uncertainty and, at times, disagreement, but they deferred to Taylor as the leader. The formation stayed together. They trusted him. As fuel levels dropped and daylight faded, the situation became more urgent. But urgency does not always produce clarity. It can produce fixation, a commitment to a mistaken assumption that becomes harder to abandon the longer it persists. By the time the aircraft were likely out over deep water, in darkness, low on fuel, with uncertain position, and limited communication, the margin for recovery had disappeared. No dramatic anomaly is required to explain this sequence. Just a series of small, human decisions made under conditions that did not allow easy correction. The investigation found evidence consistent with exactly this kind of cascading error. Not a single catastrophic mistake, but a chain, each link understandable, each one narrowing the path forward until there was no path left. This is not a diminishment of the tragedy. It is simply what the record suggests. The rescue aircraft that also disappeared that night was a different matter. PBM Mariner patrol planes of that era had a known vulnerability. They carried large quantities of fuel, and there were documented cases of fuel vapor leaks leading to explosions. Ground crews sometimes referred to them, not entirely jokingly, as flying gas tanks. A ship in the area reported seeing a flash of light in the sky shortly after the rescue plane took off, consistent with an airborne explosion. If that is what happened, the loss of the rescue aircraft, while tragic, does not require any connection to the triangle beyond coincidence of location. This is often how the legend builds. Two separate incidents occurring in the same general region become linked in narrative. The link feels meaningful, even if the causes are unrelated. Beyond Flight 19, the pattern of human error appears in many maritime incidents attributed to the triangle. Navigation mistakes, misread charts, failure to account for current drift, overconfidence in familiar routes, fatigue, equipment that was not properly maintained, communication breakdowns. In the age before GPS, before digital navigation, before reliable long-range communication, the margin for error at sea was thin. A sailor relying on dead reckoning, estimating position based on speed and direction, could be miles off course after several hours without realizing it. A pilot using radio beacons might lose signal or misidentify a frequency. Weather forecasts were less precise. Storms could arrive with less warning. And when something went wrong, help was often far away. The phrase "lost at sea" is not poetic. It is literal. The ocean does not provide second chances easily. The human error theory asks us to accept something that is, in its own way, uncomfortable. That many of the most compelling mysteries are not the result of unknown forces, but of known limitations. That the people involved were not foolish or reckless, but human. That even experience and training do not eliminate the possibility of error. They only reduce it. And in an environment like the Bermuda Triangle, reduction is not the same as elimination. There is also a quieter element to this explanation. The fog of the sea is not always physical. It is cognitive. Uncertainty accumulates. Small doubts go unresolved. Assumptions harden into beliefs. Decisions are made on incomplete information. And once a path is chosen, it becomes harder to turn away from it, even when signs suggest it may be wrong. This is not unique to the triangle. But the triangle, with its open horizons and limited reference points, makes it easier for that fog to form. This explanation is probably correct for the majority of triangle incidents. It accounts for the patterns. It aligns with what we know about human performance under stress. It fits the available evidence, in many cases, without requiring additional assumptions. But it may not be correct for all of them. And it is in that small remainder, the cases that do not quite fit, the details that resist this framework, that the mystery continues to breathe quietly beneath the surface. The electronic fog reports that doesn't fit neatly into weather, methane, magnetic variation, or human error. And these are the accounts of pilots and sailors who describe what has come to be called, in triangle literature, the electronic fog. It is a term that sounds almost poetic, but the descriptions behind it are surprisingly technical and often very specific. The most detailed account comes from a pilot named Bruce Gernon, who reported a remarkable experience in December of 1970, flying a Beechcraft Bonanza from the Bahamas to Florida. Gernon was not an inexperienced pilot. He was familiar with the route, comfortable with the aircraft, and accustomed to the conditions of that region. The flight, at least at the beginning, was routine. As he described it, the weather ahead began to change. Cloud formations appeared, not unusual in that part of the world. But one formation in particular caught his attention. It appeared to be a line of clouds, but with a distinct opening, almost like a corridor or a tunnel, as he approached. The formation seemed to shift, enclosing around his aircraft rather than remaining a distant structure. He entered it. Inside, the environment changed in ways that he found difficult to fully describe. The cloud was not just opaque, it was luminous, a kind of soft, diffused light surrounding the aircraft, reducing visibility, but not entirely eliminating it. The space felt enclosed, as though he were flying through a cylindrical passage, rather than open sky. At the same time, his instruments began to behave erratically. His compass spun. His navigation systems became unreliable. The usual reference points, both visual and instrumental, were no longer stable. The aircraft itself, he said, felt as though it was being subtly influenced, as if caught in a current that was not entirely atmospheric. He continued flying forward, maintaining control as best he could, orienting himself toward what appeared to be a brighter opening at the far end of the formation. After what he estimated to be a few minutes, he emerged, and when he did, something was different. He was approaching Miami Beach, much closer than he expected to be. The flight, under normal conditions, should have taken approximately 75 minutes. Based on his fuel consumption, his clock, and his position, he estimated that it had taken only 45. 30 minutes, by his reckoning, were missing. Gernon has told this story consistently for decades. He reported it at the time. He has discussed it publicly. He wrote a book detailing the experience and has subjected his account to scrutiny from both skeptics and researchers. He does not claim to know what happened, only that something did. And he is not alone. Several other pilots and navigators over the years have reported experiences that share certain features with Gurnon's account, not identical, but similar in structure. They describe entering unusual fog or cloud formations that feel enclosed rather than diffuse. They report instrument anomalies, compasses drifting, electronics failing or behaving unpredictably. They describe a sense of altered distance or duration, flights that seem shorter than expected, or in some cases longer, and they often use similar language: a tunnel, a vortex, a luminous fog. This consistency is what makes the electronic fog reports difficult to dismiss entirely. They are not vague impressions. They are structured experiences, described in comparable ways by individuals who, in most cases, did not know each other and had no apparent reason to coordinate their accounts. At the same time, they are not easily verified. There are no recordings of the phenomenon itself, no direct measurements taken from within such a fog. The evidence is experiential, based on testimony, on recollection, on the interpretation of events after they have occurred. The scientific community has approached these reports cautiously. Some researchers have suggested that unusual electromagnetic conditions could be responsible. The triangle region, as discussed earlier, sits above complex geological structures. It is not impossible that localized electromagnetic disturbances could affect aircraft instruments, particularly older systems that were more sensitive to such interference. If a pilot were to enter a region where multiple instruments failed or behaved unpredictably, the resulting confusion could contribute to a distorted perception of time and distance. Others have pointed to atmospheric explanations. Certain rare cloud formations, including rapidly forming cumulus systems or localized weather fronts, can create unusual visual environments. Light scattering within dense cloud layers can produce diffuse illumination, making the interior of a cloud appear brighter than expected. Under some conditions, a pilot might perceive structure, a tunnel or corridor, where none exists physically. There are also optical phenomena, such as whiteout conditions, where contrast disappears and depth perception is severely impaired. In such conditions, orientation becomes difficult, and the brain may attempt to impose structure on an otherwise featureless environment. Time perception under stress or disorientation is also not entirely reliable. What feels like a few minutes may be longer. What feels like a long duration may be shorter. Fuel consumption, while objective, can vary based on speed, altitude, and engine performance in ways that complicate simple comparisons. These explanations, taken together, offer a framework that does not require anything beyond known physics and human perception, but they do not fully capture the experience as described. What makes the electronic fog reports linger is not just the events themselves, but the way they are told, the clarity of the memory, the confidence of the witnesses, the sense that something distinct happened, something that does not fit neatly into the categories available. There is also the question of recurrence. If the phenomenon were purely random, a coincidence of weather, perception, and instrument behavior, we might expect the reports to vary widely. But the repetition of certain elements across accounts suggests, at minimum, that similar conditions can arise more than once. Whether those conditions are purely natural or represent something less understood is not yet clear. The electronic fog sits in an interesting place within the broader triangle narrative. It does not require a lost civilization. It does not require extraterrestrial intervention. It does not even require a breakdown of known physical laws. But it does suggest that the environment, the combination of atmosphere, ocean, and electromagnetic conditions, may be capable of producing experiences that are unusual enough to feel in the moment, like something more, a temporary distortion, a pocket of disorientation, a place where the usual rules seem to loosen just slightly before settling back into place. Whether that impression reflects an external phenomenon or an internal one, something in the environment, or something in perception, remains genuinely open. And like much of the triangle, it exists in that quiet space between explanation and experience, clear enough to describe, not yet clear enough to fully understand. Atlantis and the Bimini Road. In 1968, a diver exploring the shallow waters off the island of North Bimini in the Bahamas found something unusual on the seafloor. At first, it did not appear extraordinary. The ocean floor in that region is often scattered with rock formations, coral growth, and sediment patterns shaped by currents and time. But this formation stood out. It had structure, it had repetition, it had, perhaps most importantly, the suggestion of intention. A formation of large flat limestone blocks, arranged in a curved, apparently regular pattern, sometimes described as a road, sometimes as a wall, sometimes simply as a pavement, extending for roughly half a mile along the ocean floor in about 20 feet of water. The blocks were sizable. Some measured several meters across. Many had straight edges. They appeared, at least to the eye, to be placed next to one another in a way that suggested design rather than accident. The formation became known as the Bimini Road, or, in some accounts, the Bimini Wall. Divers who visited the site reported different impressions. Some saw it as clearly artificial, the remains of a constructed pathway or boundary. Others saw it as natural, but unusual. Photographs circulated. Debates began almost immediately. Mainstream geologists examined the Bimini Road and concluded that it was a natural formation, a phenomenon known as beach rock. Beach rock forms when sand and sediment, rich in calcium carbonate, become cemented together over time in coastal environments. Under the right conditions, this hardened material can fracture along relatively straight lines, producing blocks that look surprisingly regular. When these formations are submerged and exposed by erosion, they can resemble paved surfaces or constructed walls. This explanation is supported by the composition of the stones, the way they connect to the underlying seabed, and the presence of similar formations in other parts of the world. But even within that explanation, there are details that have kept the discussion open. Some researchers have pointed to what appear to be multiple layers of stone, blocks resting on other blocks, suggesting more than a single natural fracture pattern. Others have noted variations in size and alignment that to their eye resemble intentional placement. Core samples and detailed mapping have provided data, but interpretation of that data is not entirely uniform. The formation, in other words, is not conclusively artificial, but it is also not so simple that everyone agrees on what they are seeing. And then there is the timing. In the 1930s, a psychic and trance medium named Edgar Cayce, known to his followers as the Sleeping Prophet, gave a series of readings while in a self-induced trance state. In these readings, he spoke of many things: health, spirituality, history. Among them was a recurring theme: the existence of a lost civilization he called Atlantis. According to Cayce, Atlantis was not merely a myth. It was a real and advanced civilization that existed thousands of years ago and was eventually destroyed and submerged beneath the ocean. In one of his readings, he made a specific claim. He said that remnants of Atlantis would be discovered in the waters near Bimini, and he gave a time frame, that this discovery would occur in 1968 or 1969. The Bimini Road was found in 1968. For followers of Cayce and researchers in the Atlantis tradition, this was not coincidence. It was confirmation. The alignment of prediction and discovery created a powerful narrative. It suggested that Cayce's visions were not symbolic, but literal. That the location was correct, that the timeline was correct, and that the formation on the seafloor was not just rock, but the first visible trace of something much larger. The connection between the Bermuda Triangle and Atlantis is, in this tradition, direct and important. The claim is that the triangle sits above the sunken remains of Atlantis, that the unusual phenomena reported in the region are not random, but the result of ancient technology still present beneath the ocean floor. Technology that may still be active in some form, influencing the environment above it. To understand why this idea persists, it helps to go further back. Plato described Atlantis in two of his dialogues, Timaeus and Critias. He wrote of a powerful island civilization beyond the Pillars of Hercules, which most scholars interpret as the Strait of Gibraltar. Atlantis, in his telling, was technologically and culturally advanced, but became corrupt and was ultimately destroyed by a catastrophic event, sinking beneath the sea in a single day and night. Most classical scholars interpret Plato's account as allegory, a philosophical story about hubris, power, and moral decline. But not everyone agrees. Since the 19th century, researchers, explorers, and writers have taken Plato's account as a historical memory, a story based on a real place that existed in deep antiquity. Various locations have been proposed: the Mediterranean, the Azores, Antarctica, and most persistently, the Atlantic near the Caribbean. The Bimini Road, in this context, becomes more than a geological curiosity. It becomes a possible fragment, a piece of a much larger structure, now mostly hidden beneath sediment and water. There is also a geological dimension that adds a layer of plausibility, though not necessarily confirmation. The Bahama Banks, where Bimini is located, are part of a shallow carbonate platform. During the last ice age, when large amounts of the Earth's water were locked in glaciers, sea levels were significantly lower, by as much as 400 feet. This means that much of what is now underwater in that region was once dry land, not just small patches, but extensive areas, plains, river systems, coastlines that would have been habitable environments for human populations. As the ice melted over thousands of years, sea levels rose, gradually submerging these landscapes. This is not Atlantis in the dramatic sense described by Plato, not a single catastrophic night, but a slow and steady transformation over millennia. But it does establish an important fact. There are landscapes beneath the waters of the Bahamas and Caribbean that were once above sea level. If humans occupied those areas, even in relatively simple ways, evidence of that occupation could now lie underwater. Underwater archaeology is still a developing field. The tools required to systematically map and excavate submerged landscapes have only become widely available in recent decades. Much of the world's continental shelves remain only partially explored. Sonar mapping, submersible vehicles, and remote sensing technologies are expanding what can be seen, but the work is slow and complex. The Bimini Road exists within this broader context. It may be natural. It may be something more. It may be a mixture, a natural formation that was later modified or interpreted by human activity. At present, there is no widely accepted evidence that it is part of an advanced ancient civilization, but there is also no complete map of what lies beyond it. And so it remains, a line of stone blocks beneath clear, shallow water, quiet, unmoving, interpreted in different ways depending on who is looking and what they are prepared to see. For some, it is geology. For others, it is a doorway. And for the Bermuda Triangle narrative, it provides something the other theories do not: a sense of depth in time, a connection between the modern mystery and a much older story, one that reaches back beyond recorded history, into the space where memory and myth begin to overlap. Whether that connection is real or simply compelling is a question that is not yet settled, and perhaps, for now, it does not need to. Crystal energy and underwater technology. Building on the Atlantis foundation, some researchers in the triangle tradition have proposed a more specific mechanism. If Atlantis existed, and if it was technologically advanced, then the next question becomes unavoidable. What kind of technology could survive beneath the ocean for thousands of years and still do something Edgar Casey, in his readings about Atlantis, offered a very particular answer. He described the civilization as having been powered by a form of energy that used large crystals, not decorative, not symbolic, but functional. According to Casey, these crystals were capable of receiving, storing, and transmitting energy derived from both solar radiation and what he described as cosmic sources. At the center of this system, he claimed, was a structure known as the Tawoi Stone, or the Firestone. In his descriptions, this was not a small object. It was a large, engineered crystal installation, housed in a structure designed to focus and amplify energy. It could, in his telling, power cities, enable transportation, and even influence matter in ways that sound, to a modern ear, closer to science fiction than to archaeology. Casey also suggested that the misuse of this technology, specifically the overamplification of energy, contributed to the destruction of Atlantis itself. For decades, these descriptions remained within the realm of speculative or spiritual literature. But in the 1970s, when interest in both the Bermuda Triangle and Atlantis surged, some researchers began to connect these ideas more directly. Charles Berlitz, among others, proposed that if Atlantis had existed in the region of the Triangle, and if it had used energy systems of the kind Casey described, then it was at least worth considering whether remnants of that system might still exist. Not intact, perhaps. Not fully operational, but not entirely inert either. The theory suggests that structures on the seafloor, whether crystalline, metallic, or otherwise engineered, could interact with the Earth's electromagnetic field, that they might store or release energy intermittently, that they might, under certain conditions, produce localized disturbances detectable at the surface. In this framework, the various anomalies reported in the triangle begin to connect. Compass deviations, instrument failures, sudden electromagnetic interference, even the so-called electronic fog, could be interpreted as a surface manifestation of energy fluctuations originating below. Some versions of the theory extend further. They propose that these energy systems do not merely affect instruments, but also perception. That electromagnetic fields of sufficient strength or unusual configuration could influence human cognition, subtly altering the way time is perceived or the way space is experienced. This is not entirely outside the realm of scientific inquiry. Modern neuroscience recognizes that electromagnetic stimulation can affect brain activity. The question is scale and mechanism. The idea that a seafloor structure could generate fields strong enough to influence aircraft or human perception at altitude is not supported by current evidence. But it is the kind of hypothesis that sits at the edge of what is known rather than entirely outside it. Over time, the crystal theory has evolved. Some researchers no longer focus on literal crystals. Instead, they describe a broader concept of ancient energy systems, technologies that may have used materials and principles not fully understood today. In this version, the emphasis shifts from specific objects to fields and interactions. The triangle, then, becomes a kind of residual zone, a place where past activity has left an imprint on the environment, an energetic signature that persists even if the original structures are damaged or buried. Place where the interaction between geology, ocean, and whatever remains of this technology produces effects that are occasionally detectable. There have also been claims, though less widely accepted, about sonar surveys of the triangle seafloor. In some cases, researchers have pointed to sonar images that appear to show large, geometrically regular formations at depth, shapes that seem too symmetrical to be entirely natural, rectilinear patterns, angular outlines, structures that resemble, at least in low-resolution imagery, walls or platforms. These interpretations are controversial. Geologists point out that natural formations can appear highly regular under certain conditions especially when viewed through sonar, which simplifies and abstracts complex terrain into interpretable shapes. Without direct visual confirmation, submersible exploration, physical sampling, it is difficult to determine whether such structures are artificial or simply unusual geology. And yet, the images exist. They circulate. They are analyzed. They are debated. The seafloor even now is not fully mapped in high resolution. Large portions remain known only in outline. The possibility that something unusual lies beneath is not in itself unreasonable. The question is what unusual means. The crystal energy theory sits at an unusual intersection. It draws from channeled material, cases readings, which are not considered scientific evidence. It incorporates elements of archaeology, the search for lost civilizations and submerged structures. And it reaches into physics, particularly electromagnetic theory, to propose mechanisms that could connect these elements to observed phenomena. Mainstream science does not accept this framework. There is no verified evidence of ancient crystal-based energy systems operating at the scale described. There is no confirmed detection of artificial electromagnetic sources on the Triangle seafloor that could account for the reported anomalies. The theory requires several assumptions that extend beyond established knowledge, but it offers something that the more conventional explanations do not. It offers coherence, a single narrative that ties together multiple threads, the disappearances, the instrument anomalies, the geographical specificity, the historical and mythological context, into one continuous story. For those who are drawn to it, that coherence is powerful. It transforms the triangle from a collection of unrelated incidents into a system, place with an underlying cause, even if that cause is not fully understood. And it introduces a different kind of possibility, that the past was not as simple as we assume, that civilizations may have existed with technologies we do not yet recognize or have forgotten, that the remnants of those technologies, if they existed, might not be entirely silent. The ocean, after all, preserves and conceals at the same time. Structures sink, sediment covers them, time erodes them. But not everything disappears completely. Sometimes something remains. Whether the Bermuda Triangle is a place where something has remained, something technological, something energetic, something from a distant human past, is not something that has been demonstrated, but it is an idea that continues to drift just beneath the surface of the story. Quiet, persistent, waiting, like much of the ocean floor, to be more clearly seen. USOs, unidentified submerged objects. The UFO theory as applied to the Bermuda Triangle is slightly different from the standard extraterrestrial hypothesis because the triangle version has a distinctive underwater dimension. It shifts the focus downward, away from the sky and into the sea, alongside the well-known reports of unidentified aerial phenomena in the triangle region. And there are many, including observations by pilots and naval personnel going back to the 1940s. There is a significant body of reports describing unidentified submerged objects, USOs in the terminology of researchers in this field. The distinction matters. A UFO, in the traditional sense, is something seen in the air. A USO is something seen in the water, or moving between water and air in ways that challenge conventional understanding of both environments. These objects are described, often with striking consistency, as structured and mechanical in appearance. Not drifting debris, not marine life, but something with defined shape and motion. Witnesses report objects moving at high speeds beneath the surface, leaving no visible wake. Objects that descend vertically into the ocean without splash. Objects that rise from the water into the air and accelerate rapidly out of sight. Objects that appear on sonar as solid, fast-moving contacts that do not match known vessel signatures. In some naval reports, These objects have been tracked moving at speeds that exceed the capabilities of known submarines, especially when considering the immense pressure and resistance at depth. The ocean, as an environment, adds a layer of complexity to these observations. Water is dense. Movement through it requires significant energy. Sound behaves differently. Visibility is limited. At depth, pressure becomes extreme, enough to crush most known structures. And yet, according to these reports, whatever is being observed operates in this environment with apparent ease. The Bermuda Triangle becomes relevant here because of its geography. The region includes the Puerto Rico Trench, the deepest point in the Atlantic Ocean, descending to nearly 5 miles below the surface. It also includes vast stretches of deep water that have not been fully mapped or explored. Even today, with modern technology, large portions of the ocean floor remain unknown in detail. If something were operating in those depths, something structured, something mobile, it would be extraordinarily difficult to detect consistently. Most of our observation of the ocean is indirect. Sonar, occasional submersible missions, sparse instrumentation compared to the scale of the environment. The ocean covers more than 70% of the Earth's surface. The deep ocean remains, in many ways, less explored than the surface of Mars. This creates a space, not just physically, but conceptually, where unusual observations can exist without immediate explanation. Some triangle researchers have proposed that the region is not just a place where these objects are occasionally seen, but a place where they are based. An underwater installation, a base. Not ancient, like Atlantis in the previous theory, not human in any conventional sense, but active, contemporary, operating beneath the surface, largely undetected. In this framework, the disappearances associated with the triangle take on a different meaning. They are not accidents. They are not environmental events. They are interactions. The vessels and aircraft that vanish without trace are, in this telling, intercepted, retrieved, removed from the surface world by whatever intelligence or system operates below. It is a stark idea, and it is important to say clearly that it is not supported by mainstream scientific evidence. There is no confirmed detection of such a base, no recovered technology that can be definitively linked to a non-human underwater presence in the Triangle region. But the idea persists, and part of the reason it persists is that it connects with a broader set of observations that are harder to dismiss outright. The USO phenomenon is not confined to the Bermuda Triangle. Reports of unidentified submerged objects have been recorded in various parts of the world, often by trained observers, naval personnel, sonar operators, pilots. These are not always sensational claims. In many cases, they are matter-of-fact entries in logs, noting the presence of an unknown contact moving in an unusual way. During the Cold War, both the United States and the Soviet Union invested heavily in submarine detection technology. In that process, they encountered objects and signals that did not always match known profiles. Some of these were later explained. Unusual marine life, equipment anomalies, misidentified vessels. Others remained unexplained. More recently, attention has shifted back toward unidentified phenomena in general. The Nimitz encounters of 2004, involving US Navy pilots observing objects performing extraordinary maneuvers near the ocean surface. The gimbal and go fast videos declassified in 2017, showing objects moving in ways that defy simple aerodynamic explanation. These incidents are not part of the Bermuda Triangle narrative directly, but they establish something important. They show that trained military observers using advanced instrumentation have encountered objects that are not easily explained within current technological frameworks, and that these observations are being taken seriously enough to be studied at institutional levels, In that context, the idea that some of these objects may interact with the ocean, may enter or exit the water, becomes less dismissible than it once was. It does not make the underwater base theory true, but it shifts the boundary of what is considered worth investigating. There is also a quieter, more grounded way to interpret the USO reports, not as evidence of a hidden civilization or intelligence, but as an indication of how much we do not yet know about the ocean itself. New species are discovered regularly in the deep sea. Geological processes continue to be mapped and understood. Acoustic phenomena, sounds traveling through water, can produce signatures that are difficult to interpret. Underwater currents, temperature layers, and pressure gradients create complex environments that can affect both senses and perception. It is possible that some USO reports represent misinterpretations of natural phenomena that are not yet fully understood. It is also possible that some represent technologies, experimental, classified, that are not publicly acknowledged. And it remains possible, in a more speculative sense, that some observations point to something else entirely. What makes the USO dimension of the Bermuda Triangle theory compelling is not just the idea of what might be there. It is the recognition of how little of that environment has been directly observed. The surface of the ocean is familiar. The depths are not. And in those depths, the line between known and unknown is still shifting. The triangle, in this context, becomes less a place of disappearance and more a place of intersection between air and water, between observation and uncertainty, between what we have mapped and what remains, for now, out of reach. Time slips and dimensional portals. Among the strangest theories attached to the Bermuda Triangle is the one that makes the least concession to conventional physics. It asks us to consider something much larger than weather, geology, or human error. It asks us to consider the nature of reality itself. Some researchers have proposed that the triangle is a zone of temporal or dimensional instability, a place where the fabric of space-time is, for reasons not fully understood, thinner or more permeable than in the surrounding world. This is not a small claim. It moves the discussion out of oceanography and into theoretical physics, into questions about how time flows, how space is structured, and whether those structures are uniform everywhere on Earth. The evidence cited for this idea is not instrumental in a traditional sense. It does not come from sensors or satellites. It comes from accounts. Experiences. The most well-known of these is the case of Bruce Gurnham, the pilot whose flight appeared to take significantly less time than it should have. A journey expected to last 75 minutes, completed in roughly 45, with fuel consumption and position supporting that shorter duration. Gurnham himself described the experience not just as a navigational anomaly, but as a passage through something, a tunnel-like formation that seemed to compress distance. Other accounts, though less widely known, echo similar themes. Navigators reporting that their chronometers, their onboard clocks, gained or lost time without clear reason. Pilots describing flights where the distance covered did not match the elapsed time or fuel used. Sailors recounting moments where conditions seemed to shift abruptly, as though moving from one environment into another without a clear transition. Individually, each account can be questioned. Instruments can fail, clocks can drift. Human perception of time is not always reliable, especially under stress or in unfamiliar conditions. But taken together, these accounts form a pattern, not a statistically verified one, but a narrative pattern that invites interpretation. It suggests that these time anomalies are not errors, but indicators, that the triangle region contains what some researchers describe as a vortex, a wormhole, or a dimensional gateway, a region where the normal continuity of space and time is disrupted, allowing matter to pass between locations or moments that are not directly connected in ordinary experience. in physics. Wormholes are not entirely fictional. They are theoretical solutions to the equations of general relativity, mathematical constructs that describe how space-time could, under certain conditions, fold or connect distant points. But these constructs require conditions such as exotic matter with negative energy density that have not been observed or produced in any practical sense. There is no experimental evidence that natural wormholes exist on Earth, and yet the idea persists. In some versions of the triangle theory, the portal is natural, a consequence of unusual electromagnetic or gravitational conditions in the region, perhaps related to the geology beneath the seafloor, perhaps connected to fluctuations in the Earth's magnetic field, perhaps something we do not yet have the tools to measure directly. In other versions, the portal is artificial, created or maintained by an advanced civilization, Atlantis in some tellings, or a non-human intelligence in others, using technology that interacts with space-time in ways we do not yet understand. In this view, the triangle is not a random anomaly, but a functional system, a gateway intentionally placed or preserved. And within this framework, the disappearances take on a very different meaning. The vessels and aircraft that vanish without trace are not destroyed. They are displaced. They pass through the gateway and emerge somewhere else, another location, another time, perhaps another dimension entirely. They remain intact but isolated, unable to communicate back, not because they are damaged, but because they are no longer in the same continuum. It is a powerful idea. It replaces loss with relocation, mystery with transformation. And it introduces a quiet, almost unsettling possibility that somewhere those lost ships and aircraft might still exist, just beyond reach, continuing in a place we cannot access. Of course, this is deeply speculative. The physics of time and space, as currently understood, does not support the existence of stable, naturally occurring portals of this kind on Earth. The energy requirements alone would be enormous. The absence of measurable gravitational or electromagnetic signatures of such phenomena is a significant challenge to the theory. The accounts themselves, while compelling, can be interpreted in more conventional ways. Instrument malfunction can produce incorrect time readings. Fuel consumption estimates can vary based on speed, altitude, and environmental conditions. Human perception of duration can be distorted by stress, focus, or disorientation. A pilot emerging from an unusual cloud formation under pressure with unreliable instruments may reconstruct the experience afterward in a way that emphasizes its unusual aspects. Memory, especially under extraordinary conditions, is not a perfect recording, and yet there is something about this theory that continues to hold attention, not because it is proven, but because it speaks to something older than proof. The idea that there are places where the rules are different, places where the boundary between here and elsewhere is not fixed, but flexible, where time does not flow evenly, where distance is not constant, where the world, for a moment, behaves in a way that reminds us it is not fully understood. Every culture has stories like this. The thin places in Celtic tradition, locations where the veil between worlds is said to be thinner. The crossroads in various mythologies, where transitions occur. The sacred sites, where time feels altered, where events seem to overlap. These stories are not scientific claims, but they reflect a consistent human intuition that geography is not always just geography, that certain places carry a different quality, a different feeling, a different relationship to the rest of the world. The Bermuda Triangle, in the modern imagination, has taken on that role, not because it has been proven to be a portal, but because it gathers, in one place, enough unexplained detail, enough suggestive experience, enough open-ended possibility to make the idea feel not entirely impossible. Whether that feeling reflects something external or something internal something in the world, or something in the way we relate to the unknown, is not something that can be settled here. But the idea remains. Quiet suggestion, drifting at the edge of explanation, that somewhere in a stretch of ocean with no marked boundary, the distance between moments might not be as fixed as we think, and that occasionally something might pass through. Government secrecy and recovered technology, a final fringe theory, deserves mention before we move toward the counterpoint. It does not focus on ancient civilizations or unknown physics or hidden dimensions. It focuses on something more familiar: institutions, classification, silence. Some researchers believe that the United States government, specifically the naval and air force infrastructure operating throughout the Bermuda Triangle region, knows considerably more about what happens there than has been publicly disclosed. The geography supports the possibility. The triangle overlaps with areas of significant military presence. Naval stations, air bases, surveillance networks, and undersea testing facilities have operated in and around this region for decades. This is not unusual in itself. The Atlantic is strategically important. The Caribbean provides access routes, training environments, and deep water testing zones. But within this network, one facility is mentioned more often than most: AUTS, the Atlantic Undersea Test and Evaluation Center. AUTS is not theoretical. It is a real, operational installation located in the Bahamas, within an area known as the Tongue of the Ocean, a deep underwater canyon with steep sides and depths that reach thousands of feet. The geography of this canyon makes it particularly suitable for acoustic testing. Sound behaves in controlled ways there. Signals can be tracked with precision. Officially, ORTEC is used to test submarines, sonar systems, and underwater weapons. It is a place where the US Navy evaluates performance in a controlled but realistic ocean environment. Its level of public transparency is limited. This, again, is not unusual. Military testing facilities are, by design, restricted. Their operations are not broadcast in detail. Their data is classified. But for triangle theorists, ORTEC represents something more than a testing range. It represents a convergence, a highly classified installation located within the boundaries of one of the most persistently anomalous regions in modern folklore, operating in deep water, the very environment where many unexplained reports originate, and with a mission that, at least in principle, could include the detection, tracking, and retrieval of objects moving through that environment. The theory that develops from this is not subtle. It suggests that the military is not merely present in the triangle, but actively engaged with whatever phenomena occur there. That unusual objects, whether technological, natural, or otherwise, have been detected, that some of them may have been recovered, and that information about these encounters has been classified. In this framework, the inconsistencies in triangle reports begin to take on a different tone: missing records, conflicting accounts, incidents where official explanations seem incomplete, or where details change over time. These are interpreted not as errors, but as indications of selective disclosure, information released in partial form, narratives shaped to avoid revealing underlying discoveries. It is important to approach this carefully. Governments do classify information. That is well established. Military programs, especially those involving new technologies or surveillance capabilities, often remain secret for years or decades. This is not inherently suspicious. It is part of how national security systems operate. There are documented examples of programs that were unknown to the public until long after they began. The Advanced Aerospace Threat Identification Program, for instance, came to public attention in the late 2010s, revealing that the US Department of Defense had been studying unidentified aerial phenomena for years, without broad disclosure. This did not confirm any particular theory about those phenomena, but it did demonstrate that the subject itself was being taken seriously within classified channels. For some researchers, this was a turning point. It suggested that the gap between public knowledge and internal investigation might be wider than previously assumed, and that possibility extends, in their view, to the Bermuda Triangle. If unusual aerial phenomena are being studied quietly, then unusual underwater phenomena might be as well. If objects have been observed entering or exiting the ocean, then facilities like ORTEC would be among the few places equipped to detect and track them in detail. From there, the theory expands. Recovered materials, non-human technology. Analysis conducted in secure facilities, but aided from public scrutiny. The triangle, in this version of the story, becomes not just a place of mystery, but a site of ongoing classified interaction between human institutions and unknown phenomena. It is a compelling narrative, but it rests on inference rather than direct evidence. There is no publicly verified documentation showing that ATEC or any other facility in the triangle has recovered non-human technology. There are no declassified reports confirming the retrieval of unknown objects from the seafloor in this region. The claims rely on patterns, on possibilities, on the interpretation of absence as indication. And yet, the structure of the theory aligns with something real. Information is not always shared evenly. What is known within an institution is not always what is known publicly. Decisions about disclosure are shaped by policy, by risk assessment, by strategic considerations. This creates an environment where uncertainty can persist, where gaps in knowledge are filled, sometimes with speculation, and where the presence of secrecy, even when justified, can be interpreted as evidence of something more. There is also a simpler explanation for the military presence in the triangle. The region is large. It includes important shipping lanes. It offers deep water suitable for testing. It is geographically convenient for Atlantic operations. Facilities like ORTEC exist because the ocean there is useful, not necessarily because it is anomalous, but the overlap remains. An area known for unexplained reports, and an area known for restricted activity. For some, that overlap is coincidence. For others, it is a clue. The theory of government secrecy and recovered technology does not attempt to explain the Bermuda Triangle in terms of natural forces or historical events. It reframes the mystery. It suggests that the answers may exist, not lost in the ocean, not hidden in the past, but contained within systems that are not designed to share them. Whether that is the case is not something that can be confirmed from the outside, but the idea persists, quietly, like many of the others. A possibility shaped not by what is seen, but by what is withheld, and by the recognition that sometimes the boundary between the known and the unknown is not just a matter of discovery, but of disclosure. The counterpoint layer. Of course, not everyone finds these theories convincing, and there are strong, carefully argued reasons for that. When you step away from the atmosphere of mystery, the disappearances, the stories, the sense that something unusual is happening, and begin to look closely at the underlying records, a different picture starts to emerge. A quieter one, less dramatic, but more grounded. We have already mentioned the most influential skeptic in this space, Lawrence David Kushter. His work, published in the 1970s, did something very simple. He went back to the sources, not the retellings, not the summaries, not the dramatic versions that had been repeated in books and articles, but the original reports, weather logs, Coast Guard investigations, insurance filings, newspaper archives, and what he found, in case after case, was not mystery, but distortion. Ships that were described as vanishing in calm seas were in fact sailing in storms. Aircraft that were said to have disappeared without a trace had sent distress signals, indicating clear mechanical problems. Some of the most frequently cited incidents in triangle literature turned out to have occurred far outside any reasonable definition of the region. In a few cases, the events themselves could not be verified at all. They appeared in secondary sources but left no trace in primary documentation. This is not a small issue. If the foundational cases, the examples used to build the idea of the triangle as a uniquely dangerous or anomalous place, are inaccurate, then the structure built on them becomes unstable. Not necessarily false in every detail, but unreliable. And when enough of those details begin to shift, under scrutiny, the overall impression begins to change. The mystery, at least in part, starts to look like a story that has been shaped over time, not invented entirely, but edited, selected, amplified. There is also the statistical argument, which is less intuitive, but equally important. The Bermuda Triangle is not a remote or rarely traveled part of the ocean. It is one of the busiest regions on Earth. It sits between major population centers. It connects North America, South America, and Europe. It includes heavily trafficked shipping lanes and dense flight corridors. Commercial vessels, private boats, military ships, cargo planes, passenger jets all pass through this region in large numbers every day. When you have that level of traffic, incidents will occur. Mechanical failures, human error, weather-related accidents, navigation mistakes. These are not unusual in themselves. They are part of the baseline risk of operating in complex environments. Organizations like Lloyd's of London and the United States Coast Guard have examined this question directly. When they compare the rate of incidents in the Triangle to other regions with similar traffic volume and environmental conditions, they do not find a significant increase. In other words, the number of accidents is roughly what you would expect. Not lower, but not higher in a way that suggests something uniquely anomalous. This does not mean that nothing unusual has ever happened there. It means that, statistically, the Triangle does not stand out as an outlier. And that matters, because the sense of mystery is often tied to the idea that something happens there more often than it should. If that premise weakens, the rest of the narrative becomes less certain. There is also the broader reality of the ocean itself. For people who live on land, the sea can feel abstract, a surface, a horizon. But in practical terms, it is one of the most dangerous environments on the planet. Weather can change rapidly. Waves can reach heights that overwhelm even large vessels. Navigation, especially before modern systems, required constant attention and experience. A small error in the wrong conditions can escalate quickly. And when something goes wrong at sea, the consequences are often final. Ships sink, aircraft disappear, and in many cases, there is no recovery. No debris field, no clear explanation. The ocean does not preserve evidence in the way that land does. It disperses it, it absorbs it. This is true everywhere, not just in the Bermuda Triangle. Thousands of vessels are lost globally each year. Most of them do not become famous. Most of them are not incorporated into a larger narrative. They are recorded, investigated when possible, and then often left unresolved. What the Triangle does, in a sense, is gather some of these incidents and place them under a single interpretive frame. It turns a general condition, the inherent risk and uncertainty of the ocean, into a localized mystery. And once that frame is in place, new incidents are more likely to be interpreted through it. A disappearance is not just a disappearance, it is a triangle disappearance. The label shapes the perception. The instrument anomaly reports are more complicated. Compass deviations, electronic interference, unusual visual conditions, these are harder to dismiss entirely because they are based on direct experience. But they too have conventional explanations. The Earth's magnetic field is not uniform. There are regions where variation is more pronounced, and before the widespread use of GPS, navigation in such areas required careful correction. The Bermuda Triangle lies near one of the locations where magnetic north and true north have historically aligned and shifted, which could create confusion for navigators relying on compasses without proper adjustment. Atmospheric conditions also play a role. Warm tropical waters can generate sudden storms, dense cloud formations, and optical effects. Light can refract in unusual ways. Horizons can appear distorted. Visibility can change rapidly. Pilots and sailors operating in these conditions, especially under stress, can misinterpret what they are seeing. Time perception is particularly sensitive. Under pressure, with attention focused and conditions changing, minutes can feel shorter or longer than they are. Instruments, if malfunctioning or misread, can reinforce that perception. A coherent story can emerge afterward, one that feels accurate but does not necessarily reflect the exact sequence of events. This does not mean that every report is mistaken. It means that human perception, especially in complex environments, is not a perfect recording device, and that needs to be accounted for before moving to more extraordinary explanations. The Atlantis connection faces a different kind of challenge. It is not about interpretation of events, but about physical evidence. Despite extensive archaeological work across the world, on land and underwater, there is no confirmed evidence of an advanced prehistorical civilization of the kind described in Atlantis narratives. No cities, no technology, no material culture that suggests a lost global civilization with capabilities beyond those of known ancient societies. The Bimini Road is often presented as a possible exception, a formation of large rectangular stones lying beneath shallow water in the Bahamas. At first glance, it does appear structured, ordered, suggestive of construction. But when geologists examine it closely, they find characteristics consistent with natural processes. Beach rock can fracture in regular patterns. Sediment can solidify and break along lines that create block-like shapes. Over time, erosion and movement can produce formations that resemble walls or roads. This does not make the formation uninteresting. It means that its appearance, by itself, is not sufficient to establish artificial origin. And the connection to Edgar Case's prediction, while intriguing, falls into a different category. A prediction aligning with a later discovery can feel significant. But without independent physical evidence linking the two, it remains a coincidence or an interpretation. The human mind is very good at connecting patterns, sometimes too good. The USO and government secrecy theories are more difficult to address directly, not because they are stronger in evidence, but because they involve elements that are inherently hard to verify. Unidentified objects, classified programs. The absence of information can be interpreted in multiple ways. It can mean that something is being hidden, or it can mean that there is nothing to report. The challenge is that these possibilities can look similar from the outside. The principle that skeptics return to here is a simple: one, extraordinary claims require extraordinary evidence. And in these cases, the evidence available publicly, anecdotal reports, indirect indications, interpretations of gaps, does not reach that level. That does not make the claims impossible. It means they are unproven. And that distinction matters. There is also an internal complexity within the community of people who study or believe in triangle-related phenomena. They do not all agree. Some reject the Atlantis theory entirely and focus on environmental explanations. Some accept the possibility of unidentified objects, but see no reason to involve government secrecy. Some are interested in time anomalies, but do not connect them to any broader framework. These disagreements are important. They suggest that there is no single, cohesive alternative explanation that accounts for all aspects of the triangle narrative. Instead, there are multiple overlapping ideas, each attempting to explain different parts of the story. That fragmentation can be seen in two ways. as a sign that the mystery is complex and not easily reduced, or as a sign that the underlying phenomenon may not be as unified as it appears. What the skeptics and mainstream researchers tend to agree on broadly is this. Much of the Bermuda Triangle legend was constructed rather than directly observed. It emerged through a combination of real incidents, selective reporting, and gradual embellishment. Details were added, context was removed, connections were drawn that were not originally present. Over time, a narrative took shape. One that is compelling, one that is memorable, but one that does not always align with the underlying data. And yet, even after that process is accounted for, something remains, not the dramatic version, not a region where ships vanish in extraordinary numbers, or where the laws of physics visibly break down, but a place where some incidents are not fully explained, where environmental conditions can be complex and at times disorienting, where the ocean is deep and in many areas not thoroughly explored. The Western Atlantic seafloor, especially at depth, is still not mapped in fine detail. Large areas are known only through low-resolution sonar. Features exist that have not been directly observed. Processes occur that are not fully understood. When we say nothing unusual, what we often mean is nothing unusual has been confirmed. The honest answer, from a scientific perspective, is often more modest. We know a great deal, but not everything. And in that space between what is known and what is not, stories can grow. The Bermuda Triangle occupies that space, partly as a cultural construct, partly as a reflection of real uncertainty. It is, in a sense, a meeting point between skepticism and speculation, between the mapped world and the unmapped one. And perhaps that is where its enduring appeal comes from. Not from any single theory being proven, but from the fact that, even after careful examination, the edges of the story remain slightly out of focus. Not dark, not impenetrable, but not entirely clear either. And in that soft uncertainty, both the skeptics and the theorists find something they recognize. A world that is, even now, not completely known. The open questions, as we come toward the end of our time with the Triangle tonight, it seems right to slow down, not to resolve the story, but to sit with the parts that remain open, not as cliffhangers, and not as arguments waiting to be won, but as invitations, the kind that do not demand answers, but allow space for them to form, gradually if they form at all. Some of these questions have been asked for decades. Some are newer, shaped by changing technology and changing ways of thinking. None of them, at least for now, are fully closed. The first question returns us to one of the most well-known incidents. What actually happened to Flight 19? 5 training aircraft departing from Florida on a routine mission, a navigational exercise that should have been familiar. Whether that, while not perfect, was not extraordinary for the region. And then, confusion. Lieutenant Charles Taylor reporting that his compasses were malfunctioning, his position uncertain, his growing conviction that he was not where he should be. There is a plausible explanation. Disorientation, instrument error. A chain of small decisions that gradually moved the flight further from land, until fuel ran out and the aircraft were forced into the open ocean. This explanation aligns with known risks in aviation, but the details of the radio transmissions add a layer that is harder to fully settle. Taylor's description of the ocean looking unfamiliar, his sense that he was over the Gulf of Mexico when by most reconstructions he was east of Florida, over the Atlantic. This is not impossible, but it is not trivial either. It suggests a level of spatial confusion that goes beyond a simple compass error. Was it stress? Was it a combination of weather, light, and magnetic variation creating a disorienting environment? Or was there some additional factor, subtle, difficult to measure, that contributed to that loss of orientation? the official finding, cause unknown, remains. And it leaves the question open, not because no explanation exists, but because no explanation accounts cleanly for every detail. The second question moves downward. Are there structures on the floor of the Western Atlantic that warrant serious archaeological examination? The Bimini Road has been studied, and the geological explanation is, by most scientific standards, convincing. But it is also only one site in a much larger region. The waters of the Bahamas, the Caribbean, and the broader Atlantic margin were not always as they are now. During the last ice age, sea levels were significantly lower. Areas that are now submerged were once exposed land, coastlines, plains, possibly inhabited spaces. This is not speculative. It is established in geology and paleoclimatology. What remains less developed is the systematic exploration of those submerged landscapes. Underwater archaeology is a relatively young field, especially in deep or complex environments. The tools required, high-resolution sonar, remotely operated vehicles, submersibles, have only become widely available in recent decades. Large areas of the seafloor have been mapped in outline, but not in detail. And detail matters. A structure that might be invisible in low-resolution data can become clear when observed directly. The question then is not whether Atlantis exists as described in myth. It is whether there are human-made structures, settlements, or artifacts beneath these waters that have not yet been identified. This is a quieter question, but a real one, and it places the triangle within a broader scientific frontier, the study of submerged landscapes and the human history they may contain. The third question turns to the reports of USOs. What are they actually documenting? Accounts of objects moving through water at unusual speeds, transitioning between ocean and air, appearing on sonar as solid but unidentified contacts. These reports exist. They come from different times, different observers, different contexts. Some can be explained. Instrument anomalies, misidentified marine life, known vessels behaving in unexpected ways. Others remain less clear. The recent shift in how unidentified aerial phenomena are treated, moving from dismissal to cautious investigation, has created a new context for these reports. Not confirmation, but attention. If objects are being observed in the air that do not match known technologies, and if some of those objects appear to interact with the ocean, then the question of what exists beneath the surface becomes more immediate. Still, uncertainty remains. Are these observations of unknown natural phenomena? Are they related to classified human technology? Or do they point to something else entirely? The evidence does not yet settle the question, but it keeps it open, and it keeps it grounded in observation, rather than purely in speculation. The fourth question is geographical. What is in the deep water of the Puerto Rico Trench? This is not a metaphorical unknown, it is a literal one. The trench reaches depths of more than 27,000 feet. At that depth, pressure is immense, light does not penetrate, temperature is low. The environment is extreme in ways that challenge both equipment and human exploration. We have visited parts of it, but not comprehensively. Large sections remain mapped only in broad contours. What geological processes occur there is understood in general terms: tectonic interaction, sediment movement, deep sea currents. But the specifics, the fine detail, the localized features, these are still being studied. And with each new exploration of deep ocean environments, unexpected discoveries are made. New species, unusual formations, chemical processes that were not previously observed. The trench is not likely to contain something that explains all the mysteries of the triangle. But it is a reminder that even on our own planet, there are places that remain only partially known, and that what we do not know is not necessarily extraordinary. It is simply undiscovered. The fifth question is less physical and more reflective. Why does this particular stretch of ocean hold such a powerful place in the human imagination? There are other dangerous regions, other deep oceans, other places where ships have been lost, where weather is unpredictable, where the environment is difficult, but none of them have generated quite the same cultural presence. The Bermuda Triangle has become something more than a location. It has become a symbol. Part of that is timing. The rise of the triangle as a cultural phenomenon in the mid-20th century coincided with an era of expanding media, books, television, magazines, capable of amplifying and distributing stories widely. Part of it is geography. The region is accessible, visible on maps, associated with travel, with warmth, with recognizable places. And part of it is the nature of the incidents themselves. Disappearances without clear resolution. Events that leave space for interpretation. But beyond those factors, there is something more subtle, the ocean itself. We are a species that lives almost entirely on land, on a planet that is mostly water. We see the surface. We cross it. But we do not inhabit the depths. They remain, in a very real sense, outside our everyday experience. And that creates a kind of psychological space, a place where uncertainty can exist without immediate correction. The Bermuda Triangle, in this sense, becomes a focal point, a place where that uncertainty is concentrated, where questions about the unknown, not just about ships and planes, but about the limits of knowledge, can be placed. It is not that the triangle contains all of these mysteries. It is that we have chosen, collectively, to locate them there, to give them a boundary, to make them part of a story. And stories, once formed, tend to persist, they evolve, they adapt, but they remain recognizable. What we do know is that people have been drawn to these questions for generations, not always in the same way, not always with the same conclusions, but with a consistent sense that there is something here worth thinking about, even if that something is not a hidden force or a secret technology. Even if it is simply the recognition that our understanding of the world is incomplete, the triangle does not require a single explanation to remain interesting. It only requires that there be edges to the map, places where certainty fades slightly, where the line between explanation and speculation is not sharply drawn. And perhaps that is what it offers, not answers. A reminder that the world is larger than any one framework we use to describe it. That knowledge expands, but never fully closes, and that there are still places, physical and conceptual, where questions can exist without immediate resolution. As you sit with that, the details begin to soften. The specific theories matter a little less. The sense of scale matters a little more. An ocean, a region within it, a collection of stories, some verified, some uncertain. And beneath all of that, a simple, enduring fact. There is more here than we have fully seen. And for now, that is enough to leave the question open. Tonight we travelled a long way. Not quickly, not in a straight line, but slowly and with enough space to notice where the story changed shape. We began with something small, a newspaper article written in 1950. Quiet observation that a number of unusual incidents seemed to gather in one part of the ocean. No grand claims, no final conclusions, just a pattern noticed and written down. Then a name, a few years later, the Bermuda Triangle, a phrase that gave the pattern a boundary, something you could point to on a map even if the edges were never entirely fixed. And from there the story grew. It reached backward, to older journeys, to Columbus, watching his compass behave in ways he did not expect, writing it down in the careful language of someone recording what he sees, even when he does not understand it. And it moved forward, through the 20th century, through aircraft that did not return, through ships found empty, through fragments of radio transmissions, steady voices describing uncertainty in real time. We followed those threads as far as they would go. Sometimes they led to clear explanations, weather systems that formed quickly and moved with force, currents that carried vessels farther than expected, navigation that, before satellites and digital systems, depended on judgment and experience that could falter under pressure. The sea, in these moments, did not need to be mysterious, only indifferent, only vast enough that small errors could become large consequences. And then, gradually, we stepped beyond those explanations, not to replace them, but to see what else has been imagined alongside them. We visited the idea of a civilization beneath the water, not as a proven fact, but as a story that has persisted, shaped by fragments of philosophy, by channeled readings, by the human tendency to look at the ocean and feel that it might be hiding something more. We considered the possibility of technologies that do not fit neatly into our current understanding, crystals that gather energy, structures that remain quiet and buried, interacting faintly with the world above. We moved through accounts of objects in the water, not drifting, not natural, but moving with intention, described by people trained to observe carefully, even when what they observed did not fit their expectations. And then, further still, into the idea that space and time themselves might behave differently in certain places. That distance might compress, that a journey might take less time than it should, that a moment might not be as fixed as it feels. We did not settle any of these ideas. That was never the point. Instead, we let them exist side by side, the grounded and the speculative, the explained and the unresolved. Because the Bermuda Triangle, as it exists now, is not one single thing. It is several layers, resting on top of each other. It is a real place with coordinates you can trace. A region of ocean with currents, weather patterns, shipping routes, and documented events. It is also a constructed narrative, a collection of stories gathered and shaped over time, some accurate, some altered, some repeated, until they feel larger than they began. And it is something quieter than either of those, a feeling, the sense you get when you look out over water that has no visible end, when you realize how little of it you have seen, how much of it remains out of reach. There is a particular kind of weight in some of these accounts, not dramatic, not exaggerated, but steady. A pilot speaking into a radio describing confusion as it unfolds. A vessel found without its crew, the ordinary details still in place, moments that do not resolve cleanly, and so remain. Not as proof of anything specific, but as reminders. The world is larger than our maps. Even now, we have done a great deal. We have measured coastlines, tracked storms, mapped the surfaces of distant planets with remarkable precision. We have built systems that allow us to know almost instantly where we are on the surface of the Earth. But there are still places where that precision fades. The deep ocean floor is one of them. The trenches, the submerged plains, the regions where light does not reach and direct observation is rare. These places are not empty. They are simply less known. And the Bermuda Triangle sits above part of that stretch of water that is, on the surface, familiar. And beneath that surface, connected to depths that remain only partially explored. The reports we talked about tonight, the disappearances, the anomalies, the observations, exist within that context. Some will eventually be explained if they have not been already. Some may remain uncertain, not because they are extraordinary, but because the conditions in which they occurred make certainty difficult. And a few may continue to resist simple categorization. Not dramatically, not urgently. Just quietly, the triangle will still be there tomorrow. The current will continue its slow, steady movement. The sky above it will change with the weather, as it always has. Aircraft will pass through, ships will cross. Most of them will do so without incident, and the stories will remain. Not fixed, but present. Something you can return to or step away from without needing to decide what they ultimately mean. And where you are now, wherever that is, there is distance. Distance from the open water, from the uncertainty, from the horizon that does not answer back. You do not need to solve anything tonight. You do not need to choose between explanations. You can let the questions stay where they are, out there, somewhere beyond the edge of what is fully known. The triangle keeps its own shape, its own silence. And whatever it is, or is not, it does not require anything from you in this moment. So you can let the details drift, the names, the theories, let them settle the way the surface of the ocean settles after something has passed through it, until what remains is simpler, of depth, of a world that continues quietly beyond the parts we have already explained. And tonight, that is enough to rest with. Nothing resolved. Nothing demanded. Just the awareness that there is more out there than we have fully seen, and that it will still be there, unchanged, in the morning.